Okay, here's some videos on exponential growth. So these are some practice problems that I kind of made up that are similar to the ones that are in our textbook. And number one is a population of a certain insect obeys the law of uninhibited growth given by P of t equals 700 e to the 0.03 t. T is in days. So if we go back and look, remember, growth is continuous. It doesn't happen in like little discrete spurts. It's constantly happening as we keep adding molecules or adding insects or adding anything. So it happens continuously in a manner of speaking. So we can use our good old PERT, which is how we calculate interest continuously. Amount equals principal times e to the RT. And this just becomes, when we talk about more general applications, the amount we have at any time, if we were talking about continuous growth, is equal to a sub 0. That's the initial amount. E, this is the growth constant K, and T is the time. So if we look at this number one problem here, they give us the actual formula, and you can actually see what the K is. In this case, the K is 0.03, so you can write that down. The K equals 0.03 T, 0.03, which is positive, so we're talking about exponential growth. And T is in days. We got T is in days, and my initial amount, I start with a sub 0, is equal to 700. And you can kind of see that in the formula. So if you're familiar with the formula, which you need to be, then you can see these elements. So letter A, determine the number of insects at time t equals 0. So if we look at A, you can see it down here. When t is 0, you can see that P of 0 equals 700 times e to the 0.03 times t is 0. So that's just going to be 700 times e to the 0. And e to the 0 is 1, so it's just going to be 700 times 1, which is 700. And that kind of reaffirms that the initial amount is 700. So I think you can see that. So they're just asking you these questions to see if you're familiar with the formula and the setup. Letter B, what is the growth rate? Well, the growth rate I already told you. K equals 0.03. And you can actually see that in the formula. That's what's in front of the T. As long as you're familiar with your general formula up here, you should be okay. And letter C, what is the insect's population after 22 days? So we have our K, so we just can substitute our data. So we want to know when T is 22, so this would be actually P of 22. And that, and just put that in the formula, 700. So every time I see a T, I put a 22. So that's going to be 700 times E, so 0.03 times 22 days. That's the number of days, all right? That just ends up being 700. And if you can simplify that, that's always the best thing to do. So that's going to be E. And if we multiply this, it actually ends up being 22 times that. You can work that on your calculator, 0.66. And then when you put this in your calculator, and I've got two different kind of calculators here. A lot of you got these TI calculators, and then when you put the E in, you'll get a caret. All right, so if I put second natural log, turn on, second natural log, then you got your E caret parentheses, and then you put your exponent in. And then these little $1.99 calculators we got at the 99-cent store, you put shift natural log, and then you get E, then you have to put your parentheses, and that's going to give you your exponent. So if we clear that and we want to put this in, we could put this in as 700, and then I'll put shift natural log, and I get the E. Then I got to put a parentheses for the exponent. This doesn't provide the parentheses, and E to the 0.66 parentheses, and that should give it to you. So that'd be 700 times E to the 0.66 power, and that equals 1354.35. So that's how many of these insects we'll have after 22 days. Okay? And I'll just try to indicate those for you so you can see those. Your calculator stroke should be like this. And then, you know, if you've got the caret, it's going to look a little bit different, so it'll be just 700. And then E, parentheses, 0.66 equals. And that's how you would get it. Okay? On these little calculators. All right? And then letter D. When will the insect population reach 1600? So we want our population to be 1600, so letter D. Oh, here's letter D, sorry about that. So 1600 will equal 700 e to the 0.03 t. So we want to solve for t. So now we have to, we're going to eventually use the logarithm, but we're going to divide both sides by 700 first so we can move that. So we'll have divide both sides by 700. We can cancel that, so we have 16 over 7, cancel the zeros. And that equals e to the 0.03 times t. Then I'll take the natural log of both sides. The natural log of 16 divided by 7 equals the natural log of e to the 0.03 t. Then I can bring this down using my third property of logarithms. So that's the natural log of 16 divided by 7 equals 0.03 t natural log of e, but the natural log of e is 1. And then I divide both sides by 0.03, so I get the natural log of 16 divided by 7 divided by 0.03 equals t. All right? And then in our calculator we can do that. And I would do that like this. I would just say ln, and I put a parentheses because I have a fraction, 16 divided by 7, parentheses divided by 0.03. And that would work the same on either calculator, so I'll just use this one. Let's clear that. And then we have ln, parentheses for the fraction, 16 divided by 0.0, I'm sorry, back, excuse me, divided by 7, parentheses, and then I'll divide that by 0.03, and we get 27.55 days. All right, 27.56 if you round off because you got 0.555. So about 27.56 days. Okay. So we're just using the formula, and these are pretty basic problems. And then the last one, when will the insect population triple? Now we've done these also. When will the insect population triple? Okay, so we've done these before, so this is letter E. So we know that the A sub t equals my initial amount, A sub 0 times e to the, in this case, 0.03 t. So we want to know the t when the insect population triples. Well, that means that the amount I have compared to the amount I started with, this would be 3 times as much as this. If this was 100, this would be 300. So we know that A of t divided by A sub 0 will be 3. Let me move this up a little bit here so you can see this here. So when I divide, I just have A sub 0 over A sub t over A sub 0. And then what's left is, that's 3, and that's going to equal over here just the e to the 0.03t. And I take the natural log of both sides. And I can bring that in front, so I have the natural log of 3 equals 0.03t natural log of e, but that goes to 1, that's 1. So I just divide both sides. I guess I can do it over here. And I have the natural log of 3 divided by 0.03, and that will equal t. And then you can put that right in your calculator. That should be pretty easy. Let's clear this. And ln 3 divided by 0.03, and we get 36.62 days. So 36.62 days. That's approximately the time it takes for the population to triple. Okay? So you can see how you use your calculator. Again, these are the ones that are only $1.99, so they're a pretty good deal. And there you got that. Okay, so that's kind of a basic problem. And again, this basic problem, so you can always go back and take a look at it. And that answers a lot of basic questions about the formula.